I'll be solving for the value of m. Now, to do this, here we have, let's rewrite this equation. 3 to the power of m minus 2 to the power of m equals to 65. Now, I'm going to do something here. By rewriting this, I have 3 to the power of m, then raised to the power of 2 over 2, minus 2 to the power of m, raised to the power of 2 over 2 equals to 65. If you look at this expression, this is still the same thing as this because 2 over 2 is equals to 1, and which still gives the same value. Now, let me rewrite this. I can rewrite this as saying 3 to the power of m over 2 squared. Okay, recall this law of indices that says that a to the power of m n is equals to a to the power of m times n. So this is the rule I'm going to use here. So here also we can have this to the 2 to the power of m over 2 squared equals to 65. Now I'm going to do something in here. Let x to the equals to 3 to the power of m over 2, and let y to be equals to 2 to the power of m over 2. Okay, good. Now, by doing this, if you plug in the value of x here and the value of y here, then here I'm going to have x squared minus y squared equals to 65. And here, I'm going to use something we call the difference of two squares. So for the difference of two squares, this x squared minus y squared can be written as x plus y, x minus y equals to 65. And this equation can be rewritten in how? Okay, let me rewrite this. Here I'm going to have x plus y. Here I'm going to have x minus y equals to 65 is the same thing as saying 13 times 5. Now, there's something very good here that you need to pay attention to. Here I'm having the positive value of these quantities, and here I'm having the negative values. Here we should know that x plus y is greater than x minus y, because provided both x and y are positive, the sum of two numbers is greater than the difference of two numbers, two positive numbers. So here we can conclude that x plus y equals to 13, and here x minus y equals to 5. Simultaneously, we can solve this by adding these two equations together. If you solve this by adding these two equations together, x plus s is going to give us 2x. The y is going to be eliminated, and 13 plus 5 is going to be 18. Dividing both sides by 2, here I'm going to have my x to be 9. Then let's solve for y. Recall from the previous page that we have x plus y to be equals to 13, and we have x minus y to be equals to 5. And we have that x equals to 9. So if you plug in x into the first equation, so we can have 9 plus y equals to 13. And my y is going to be 13 minus 9. Y is going to be 4. Therefore, we have x to be 9 and we have y to be 4. So these are the two values we have. Then how do we get the m, which is our major focus? Recall that here in the previous slide, I said here we have x to be equals to 3 m over 2. Yes. So here we have our x to be 9, which is 3 m over 2. By rewriting this 9, we have this to be 3 to the power of 2, okay, equals to 3 to the power of m over 2. And having a very good look at this, you can see that we have the same base. And when you have the same base, you can equate the powers together. So 2 equals to m over 2. And here by cross multiplying, you can say that m is 2 times 2, and our m is 4. Our m is 4. So this is something that we have here. And you can check. If you go back to the given equation, which is 3 to the power of m minus 2 to the power of m. 3 to the power of m is 3 to the power of 4 minus 2 to the power of 4. So 3 to the power of 4 is 81. 2 to the power of 4 is 16. If you subtract it, we still have 65. Thank you very much for watching. Please, if you find this very interesting, don't forget to subscribe. See you next time. Bye.